Okay, welcome to this lecture tutorial. We're going to begin looking at properties of materials. So this is one of the simplest topics that we have, I think, in engineering science, remember, apart from the introduction. Okay, so here we are just trying to understand the materials that we use in the field. These are materials that you have seen on a daily basis in your workshops and also in other in other fields. So number one, we need to understand what stress is. Stress is a force per unit area, and that is a formula. Stress is force per unit area. The formula is stress sigma is equal to force over area. Now we need to understand that force is measured in newtons. This you already know this. We have discussed this quite a number of times. Area is measured in square meter. So the units for stress is force over area is Newton per square meter or Pascal. Okay. So we have understood what stress is. So if you have got a force that is pulling this object like that, this force divided by the cross-sectional area of this object, that's what will give us stress. So the bars or the materials over which the force is going to act can be rectangular, can be circular. So you have to find the cross-sectional area. For example, for a rectangle, it will be L times B. If it's a square, L times L. This is pi D squared over 4 or pi R squared, whatever. So once you find this area, you also find maybe this area if it's circular. Then you put it there, then and the force that you are given, then you find the stress. Okay. Then from there, we also have strain. Strain, let me write it in a way that you'll be able to see it. Strain. Okay. Now, strain is the deformation produced by stress. Okay, it's a deformation produced by stress. So there is a close relationship between stress and strain. And the strain is E is equal to X over L. Okay. That is the formula, and it has got no units because this is distance, this is distance. Let us explain it further. Okay. So, if I have got a material that is 2 meters and it's being pulled by this force F, when it's being pulled, it's going to extend by some distance. Okay, it's going to extend by some distance. Now this is the original length, 2 meters. Then when you pull it, it's going to extend by another distance called x. Therefore stress is equal to the elongation over the original length. So if this force is 2 kilonewton, then strain is going to be strain is going to be this x, the elongation, and the original length. We have got all these which will help perhaps find the stress and other things. So you should get to know that. Okay. Then sometimes it's not only elongation. Sometimes the force may be pushing inside. What will happen is this thing is going to shorten. Okay, it's going to shorten because you are compressing it. So you have got the original length L and the shortening here, which is X. Therefore, strain will still be X over L. Okay, so that's what strain is all about. All right. Then we have got what we call the Young's modulus. Young's modulus. This is a material of a property. We usually represent it by E. So Young's modulus is simply the ratio of stress to strain. So you have found your stress, you have found your strain, you can calculate Young's modulus. You can be given Young's modulus, you are given stress, you are told to find the strain. You can be given Young's modulus, you are given the force, you are given the diameter, you can find the stress, then you find the strain. So how this works is, we know that stress is equal to force over area, while strain is X over L, not so. So we can write that to be Young's modulus is equal to this guy will go on top there. So it will be F times L over area multiplied by the extension. Therefore, we can find this direct whatever we want, the extension E and other things, FL over AX. So that's Young's modulus. Then now we have to understand the Young's modulus sometimes can be found from the material properties that you have been given. Okay. Then we have to know some other terms. Okay. The first term that we would want to define is Hooke's law. Okay, this is the other term apart from stress strain Young's modulus. Hooke's law, it states that within the limit of proportionality, okay, within the limit of proportionality, the extension of the material, is proportional to the applied load, That is Hooke's law. In short, within the material's elastic limit, there cannot be plastic deformation. Okay, we understand those things. Then we have got yield strength. That's now in relation to Hooke's law. Yield strength, when a material is pulled, like a spring, you can pull the material at a certain point. Once you stop pulling it, it will return to its original shape. Now that's where Hooke's law apply. You pull the material, you stop pulling it, it goes back to its original shape. It's within Hooke's law. Then, as you pull the material, at some point it will stop coming back. We say the material has yielded. So this is the point, the yield strength, this is the point where the material begins to deform plastically instead of elastically, okay? This is the point where the material begin to deform plastically. You need to know this definition. This is where the material begin to deform plastically. Okay. Then we have got the ultimate tensile strength. So this is the maximum stress. This is the maximum stress the material will be subjected to before failure. Before failure. Okay. So you really need to know these definitions and you know them by head. Of course, we are going to do quite a number of definitions and the assumptions in this topic. Okay. So you have known what stress is, what strain is, their formulas. You have also known Hooke's law. You have known tensile strength. You have known yield strength and other things. So we really need to know that. Then we know we talked about strain, which we said the strain is X over L. There is what they call strain percentage. So once they ask you for strain percentage, first of all find strain, then multiply it by 100. So that is what they call strain percentage. I just thought of mentioning this. In case you meet a question, it should not be something harder. Okay, let's meet in the next tutorial.